We're always told that energy is forever, that it can't be created or destroyed. So why does everything run down? Why does your phone battery die? This isn't just some simple question. It's actually a deep paradox that reveals a fundamental rule about how our entire universe works. So let's unravel it together. Right? You've heard this a million times. Energy is conserved. But if the total amount of energy in the universe literally never changes, why are we constantly being told to save it? Why do things just stop? It feels like a total contradiction, but I promise by the end of this, you'll see why it makes perfect and kind of profound sense. All right, part 1, energy is forever. To solve this puzzle, we have to start with the first unbreakable rule of cosmic accounting. You can't just get rid of energy. And this is the big one, the first law of thermodynamics. Think of it as the universe's most strict accounting principle. It basically says you can't get energy from nothing and you can't make it disappear. All you can do is change its costume. And believe me, energy wears a lot of different costumes. It's the kinetic energy of a moving car, the potential energy stored in a book that's sitting on a high shelf, the chemical energy packed into your food, even the thermal energy coming off a radiator. The first law just says the universe is constantly shuffling energy between these forms, but the total amount? That never ever changes. Let's look at a super classic example, a falling ball. Okay, picture it. At the very top, right before you let go, all its energy is stored up as potential energy. As it starts to fall, that potential energy transforms into the energy of motion. That's kinetic energy. Then, thud, it hits the ground. But that kinetic energy doesn't just vanish. Nope, it transforms again, this time into a little bit of sound and a tiny bit of heat in the ball and the floor. The total amount of energy is exactly the same as it was at the very top. Okay, part 2, the problem of wasted energy. So the accounting seems perfect, right? All the energy is there. But this is where our everyday experience kind of throws a wrench in the works. If no energy is lost, why isn't everything 100% efficient? Yeah, think about it. If all the energy is still right there, why can't the ball just use it to bounce right back up to where it started? Why do all real-world processes, everything, seem to have this one-way direction towards running down? This question reveals a massive gap in our understanding, a gap that the first law just can't fill on its own. So here's the key. You have to realize that not all energy is created equal. On one side, you have useful, concentrated, ordered energy. Think of all that juice packed into a car battery. It's organized and ready to do work. On the other side, you have disordered, wasted energy. Think of the faint, low-level heat that is spread throughout a room. You can't gather all those little bits of warmth back together to power anything. It's just there. And here is the hard truth of it all. Every single time energy changes form, a little bit of that high-quality, useful energy gets degraded into a low-quality, wasted form, usually as heat that just spreads out. That's why your car engine gets hot, and it's why no machine can ever be perfectly efficient. But why does this happen? What's the driving force? And that brings us to part 3, Law 2, the Great Spreading Out. The answer to why is the second, and you could argue much more profound law of thermodynamics. This one isn't about the amount of energy at all. It's about its inevitable tendency to just spread out. The key concept here is a word called entropy. Now, I know it can sound a little intimidating, but the core idea is actually super simple. Entropy is just a way to measure disorder, or maybe more accurately, how spread out energy has become. Low entropy means energy is concentrated and orderly. High entropy means it's all dispersed and messy. The best way to think about it is your own bedroom. A perfectly tidy room, every book on the shelf, every shirt folded in the drawer, that's a state of low entropy. There's really only one way for it to be perfectly tidy. But a messy room, well, that's high entropy. Clothes on the floor, papers everywhere. There are thousands, maybe millions of ways for it to be messy. And which way does the room tend to go all by itself? Towards messiness, of course. And this is exactly what happens with energy. A hot cup of coffee in a cool room contains concentrated low-entropy heat. But it doesn't stay that way, does it? The heat naturally spreads out, warming the air around it until the coffee and the room are the same lukewarm temperature. The energy has dispersed, and the total entropy of the room has gone up. You will literally never see the warmth in the room spontaneously gather itself back into the cup to make it hot again. And that simple observation, that is the second law of thermodynamics. It states that the universe is fundamentally lazy. It always moves from order to disorder, from concentration to dispersal. This is the arrow of time. This is why things run down. It's not that the energy is gone, it's just that it is spread out to a point where it's useless. So for our last part 4, quality, not quantity. You see, these two laws don't contradict each other at all. In fact, they work in perfect, if kind of frustrating, harmony. Here's how you connect the two. This table just sums it up perfectly. The first law, which governs the quantity, has a slogan, "You can't win." That means you can't create energy out of thin air. But the second law, which governs quality, is even tougher. Its slogan is, "You can't even break even." Because in any real process, you are always going to lose some of that useful, quality energy to the unavoidable increase in entropy. So let's go back to our falling ball one last time. The first law acts as the accountant, right? It confirms that every last bit of energy the ball had at the top is still present at the bottom. But the second law is the one that explains the outcome. It explains why the ball can't bounce back. Because its useful, organized kinetic energy was irreversibly taxed, converted into useless, disorganized heat and sound that just scattered out into the world. And really, if you take away just one thing from all of this, let it be this idea right here. The first law is the universe's accountant, making sure no energy is ever truly lost from the books. But the second law, that's the universe's unavoidable tax on every single energy transaction. A cut always goes to entropy. And that is why batteries die, why fuel runs out, and why, ultimately, everything runs down.